In this lesson, we're going to discuss the scientific notation of representing numbers. Scientific notation comes very useful when we are working and presenting very large or very small numbers. So when we are dealing with numbers in the scientific notation form, they are given in the form a times 10 to the power of m. Now, a must be a number that is equal to 1 or greater than 1, but less than 10. So it cannot be 10 or more. Or if we're dealing with negative values, a must be greater than negative 10, but less than or equal to negative 1. And the power there can be positive or negative. That is why it is an integer. Let's have a look at some examples. So we need to write the following large numbers or small numbers in scientific notation. So what we do is we look at this big number and we think of a way of representing this big number as a value between 1 inclusive and 10. So if I take the first three digits 1, 2, 5, if I write them as 1.25, that is in fact a number between 1 and 10. But then I need to write times 10 to the power of an index, so that if I have to rewrite this in as a basic numeral, I can expand it to come back to this large number. So I've decided to put the point here. How many times do I need to move it to go at the back where it is originally? 1, 2, 3, 4, 5, 6, 7. And so the power here is 7. It is positive because we went to the right. In this case, it is a very small number. It is a very small whole number. So the only difference is that we've got a negative at the front. I look at these digits 5, 3, 0, 4, and to present that as a number between 1 and 10, I will put 5 as the first digit point, 3, 0, 4. Again, times 10 to the power of what? So that it becomes this number again. Let's have a look. So 1, 2, 3, 4, 5, 6, 7, 8. So the power is 8 because we went towards the right. A very small number here. So I look at the digits that are not 0. The first one is 4. 401. I can present that as 4.01. Notice how I always have one digit in front of the decimal point. 4.01 times 10 to the power of 1, 2, 3, 4, but it's negative because we went towards the left. Negative 0.0018, again, we've got negative. I look at the 1 and the 8, so I'm going to write it as 1.8 times 10 to the power of 1, 2, 3, but it's negative because we are going to the left. Now let's do the opposite. Let's write these numbers, which are in scientific notation, as basic numerals. So I've got 3.401 times 10 to the power of 6. So I need to move the decimal point 6 times because it is positive in index. We need to move it to the right. And so we're going to go 1, 2, 3, 4, 5, 6. And so the answer would be 3401 and 1, 2, 3 empty arcs, which needs to be filled in with zeros. 4.8 times 10 to the power of negative 4, the power is negative, and so we need to go to the left. That means it is a small number, so the decimal point needs to go 1, 2, 3, 4. So it's going to give me 0.3 zeros there, and then the 4 and the 8. Another useful thing when we are dealing with big numbers or very small numbers with a lot of digits are significant figures. significant figures are counted from left to right, starting at the first non-zero digit. So for example, 5.018 times 10 to the power of 5, it is showing 4 significant figures, 1, 2, 3, 4. So let's have a look. If we have these big or small numbers that we need to change in scientific notation, however, this time using 2 significant figures. So let's have a look. It's similar to rounding. So the first 2 significant figures are the 6 and the 3. So if I need to present it in scientific notation, that's going to be, I have to look at this value behind the 3, and if it's 5 or less, it is not affecting the 6 and the 3. So it's going to end up being 63. However, I need to present that as a number between 1 and 10, so I put the decimal point there, times 10 to the power of 1, 2, 3, 4, 5, 6. So it is similar, obviously, to scientific notation. However, we've got an extra step here. We are giving it to 2 significant figures. In the next question, we've got, this is the first significant figure, this is the second. So our cutoff line is here. This 8 is going to affect the 0 in front of it. So it's going to end up being negative 2.1 times 10 to the power of 1, 2, 3, 4, because we are going towards the right. This very small number, the first significant figure is 5 and the second one is 6. This 9 here is going to affect this 6, which is going to change into a 7. And so now we've got 5.7 times 10 to the power of what? Let's have a look. 1, 2, 3. It's negative 3 because we are going towards the left. The rest of the digits, such as the 0, 4, drop, just as we normally do when we are rounding.